All right, so first off, I should mention something about the qualitative data. I just realized when I looked at this again. So let me show you qualitative data. I said lower limit, upper limit. Oh, I did those backwards. This is the upper limit 0.2016, and this is the lower limit 0.0957. So just wanted to note that. All right, so my quantitative data I've chosen is minutes in commute time. And so I have the number of minutes here from row 2 down to row 51. So I'm going to go ahead and find my mean first. So I'm going to do the average of, and I'm going to do 2 through the 51 that I have here, just like that. And that's going to give me my average for the sample. That's x bar. Now I'm going to find the standard deviation of the sample. And this is again A2 through A51. And you'll see again that was all the data points there. There's my standard deviation and my sample size. I'm going to count all of these values in A2 through A51, and again showing you there they all are, and there is my count. Now, once I have all those values, the next thing I need is my critical value. Now, the x bars are not distributed normally because I do not know the standard deviation of the population. Even though my sample size is above 50, the materials that we are using, and this is not consistent from some material to others, can be differing ways of making this decision, but the materials that we use, the Triola book in my class or the Brace book even that I use in some of my classes, both of them use a deciding factor of whether the standard deviation of the population is actually known. When it is not, we use the student's t distribution as the distribution for the x bars. So the student's t distribution is the t distribution, and we are going to be using the t inverse because we want to find the critical value based upon a probability. So an 80% confidence level, that means that 0.1 is in each tail. So if I want the positive value, that means there's 0.9 to the left, and then the t distribution also needs degrees of freedom. Degrees of freedom is 1 less than the sample size, so that would be 49. So there's my t. Now I may want to round that, so I'm going to go ahead and round that right here as 3 decimal places. So I'm going to format it, and I'm going to say that my sample size here is a number, and I'm going to use 3 decimal places. And so there's my value. Now the next thing I need is my standard error. Now my standard error is the standard deviation of the sample divided by the square root of the sample size. So this is equal to the F3 divided by, and this is the square root of, and this is F4. And so now we have that value. Now that's my standard error. Again, I may want only 4 decimal places, so you can round this number to 4 decimal places, just like that. Now the next thing that we have, and it's only showing 4, there's probably more actually being used to compute it. Having more is never a problem. Now the next thing that I'm going to do here is I'm going to compute my margin of error. My margin of error is always the critical value times the standard error. So this is going to be equal to E6 multiplied by E8. And that's my margin of error. Again, I'm going to show it only out to 4 decimal places there. Also keep it in mind here that there are probably more decimal places in there. 4 decimal places. 4. And there we go. Now I have my margin of error, and now I want to create my left and right values for my lower and upper limits of my confidence interval. My confidence intervals for the mean starts with the mean of the sample, that's in F2, and for the lower limit it's going to subtract that margin of error, which is in F10, and there's my value. And on the upper limit, that's going to start with my mean, F2, and it's going to add my margin of error, F10. And there we go. And so now you see that I have my upper and my lower limits for my confidence interval, and I can round these appropriately. I'm just going to go ahead and copy G12 and copy G14, no, 13, and then I will show these appropriately, format those cells, and I'm only going to show one more decimal than the original data. If you look through my original data all contains whole numbers, so I'm going to use the nearest tenth to round these to, and I should put that these are in minutes and minutes here as well. And so my confidence interval would be that mu is between 85.8 minutes and 93.4 minutes. And that would be how I would do a confidence interval for my true mean of the population.